Hello, my name is Auhon and I am a rising junior at Homestead High School. For my project, I made a ball tracking robot with computer vision, and here's a quick demo. As you can see right now, what the main thing it does is use software to track this ball as well as distances. So you can see that when I move this ball around, you can see the camera here can track the ball using a bounding box around it, as well as find the center. Additionally, you have many outputs over here, all of which are the distances from each of these three ultrasonic sensors, as well as certain values like where the ball is relative to the camera's center. So to do this, I needed to do two things. Number one was to get the actual ball tracking using the camera, and number two was to track distances using the ultrasonic sensors. To get camera input, it was fairly easy because I used the Raspberry Pi built-in camera module here, which is just attached to the actual board itself using the ribbon cable that came with it. Now, to actually use this, I had to just create a variable that housed this camera, and then I could gain input. And what I did with this input is take each frame and erode and dilate the colors in that frame so that the specific shade of red that this ball is would be changed to white, and every other color in the frame would be changed to black. Now, what this did is it replaced every frame with just a full-on black rectangle with just one white blob, which signified where the ball was. And once I had that, I could track it by making a bounding box around that blob. Now, once I had that, translated to this blue box that you can see here, and then I used that number to get the center of the box, which you can see as that orange dot here. So once I had that, I could identify where it was relative to the center of the camera by using this center dot here. And you can see these numbers here. This is 14.5, which means that the ball is 14.5 degrees off center. So if I move that, you can see the number gets larger if I move it farther to the left, where it's now 44.5. And it goes into its negatives when it gets too far to the right, where it's now negative 50. Now the number on the right is by default around 72, 73, and that is the angle that the ball is at. So you can see if I lift the ball higher in the frame, the angle shrinks, and if I move it lower, it would go lower down to 90 or 100. And yeah, so that's it for the camera. And the second thing I did was using ultrasonic sensors to find distances. So this was a little more challenging than the camera, but still not too difficult. Each sensor has 4 pins, a VCC pin, a ground pin, and a trigger and echo pin. Both VCC and ground are power related, and trigger and echo are related to getting input and output. So what I did was take the VCC and ground pins, all of which are black for my ultrasonic sensors, and plug them into this basic breadboard, where I then powered them using the Raspberry Pi. Now, I still needed to get input and output, so I used the trigger and echo pins and plugged them in to the Raspberry Pi directly. So once I had that, I could get input and output, and I could find the pulse length it took for an ultrasonic sensor to send a wave to an object and back. So once I had that, that gave me a certain time, and I converted that time to distance using algebra, and that gave me a number in centimeters. So you can see we have 3 variables here, distance r, distance c, and distance l, which signify the distances that each sensor have, the left sensor, center sensor, and right sensor. So you can see that if I take my hand and put it over the left sensor, then the distance becomes far smaller, but if I lift it back up, it'll become far longer again. The same applies for both the center and the right. Now, these numbers alone mean nothing, and in my next steps, what I need to do is I need to make the motors on my robot respond to these inputs. So, for example, if the ball is too far, then it should move forwards. Or if the angle of the ball is too far to the left or right, then it should either turn left or right, depending on where it should go to track the ball itself. So additionally, I would also need to create my own drive base that I mentioned in my first milestone, because this one is not good for housing all of the components.